Hi, everybody. How y'all doing? Awesome. As Ryan mentioned, my name is Mizell. It's great to be here. Quick question for you. How many of you believe that every software company, or every company is a software company? Raise your hands. Not many. Okay, that's interesting. So I think it's interesting. We're in a landscape. You can't hear me? The echo. Okay. Is it that bad?
It's not your fault.
Not my fault? Yeah, I hope you guys can hear me okay. Anyway, so we live in an era where software is king, right? And so it's interesting that as we think about how we deal with software every day, there's a whole change in the modern world, right? So by way of background, I'm a software engineer by trade, and so I lived this back in the day where we wrote software, but we did our own builds, we did our own deployments, we did all the things that we needed to do because we didn't have all the rules and regulations and things in place. Security was more of a trust but verify, but now we live in a world of zero trust, right? So we'll talk about securing our pipelines today, and I think it's interesting. We call it, DevOps, truly DevSecOps, right? And that's a mind shift. It's a shift-left mindset. I think a lot of things that I'm going to talk about are not new to you, but I just want to review some of the concepts as we build on where we're headed, right? So this shift-left mindset means we need to work better together. I remember when I was in writing software, working with the security team, not fun, right? And it's ironic now that I'm in the security landscape and I see it from the other side, and I'm like, wow, we should have started working with them sooner because we are always chasing from behind, right? And so as we start looking at the landscape we're in, we need to think about pipelines, automation, reducing risk. We can't let things go by way of manual processes anymore because it increases that landscape, increases the ability to have attack surfaces and the like. So you have to think about all those things. So let's talk about some of the components that are built in it. And you are very, very familiar with a lot of these, right? So first thing is I need to know who's checking in the code. COVID brought some very interesting things to us. Developers were working from home, and they didn't work for just one company. They worked for two. They worked for three, right? And they were outsourcing their code to somebody else. And it was being checked in from countries all over the world. And it's kind of frightening because you don't know who's touching your code. You have no idea. So it's interesting, if you follow along with this stuff, GitHub actually started putting in checks. So you actually had to have a token or a certificate that was against the MAC address of your laptop, guaranteeing that it was you checking in the code and not someone from Istanbul or some other country, right? So that was the first thing. How do I know who's checking in the code? I need to know for sure. I need to validate who has access to source code to keep it secure. Second thing, you have to have a secure build process. I think we've seen this across a lot of different vulnerabilities where if anyone has access to the build, they can manipulate, they can change, right? You don't know what you're deploying anymore. So you have to know, and you have to have limited access to this build cycle. So having it being external of your dev team, having it be part of a pipeline build that happens in a safe, secure environment is critical. I'm sure a lot of us do static code analysis. This came along a while ago. Your black ducks, sonar cubes and the like. Everyone does this, but if you're not doing it, you have to do it. It's interesting. I'm old school. When I wrote software for a living, we made sure we only knew what was brought down and put in our app, right? So we all use open source libraries. We all use third-party builds in our software. Tools like Maven download the world. So if you're familiar with that concept, it just downloads every dependency under the sun. You have no idea what's in your build. And the next thing you know, you're a log4j vulnerability. You don't even use it. You're like, what? Right? So you have to know. So I'm a big fan of knowing everything that goes into my code. So you have to know. You have to do QA testing, pen testing. Make sure that your code is safe, right? So as we go back to what we talked about in the beginning, every company is a software company. It's one of our most critical assets. If we put things out that can be hacked or are vulnerable, then we increase our risk vector. Code signing. This is going to be our big topic. If you're not signing your code, then you're putting yourself at risk. Not just, for those who are selling software, you don't have a choice, right? Because no one can install that software if it's not trusted, or most can't install software. But if you're not signing it internally, then how do you know what you're deploying? And it's amazing to me how many companies I work with that don't actually sign code. They don't know what they're deploying. And I could tell you stories that I can't share here, but of types of software that are running in organizations they didn't even know was running, right? So you have to know what is running, and it's got to be signed with your trusted authority. It needs to be stored in a secure repo. Again, think about all the steps along the way, right? Everything is happening, I sign it, I store it. This is my favorite last step, verify it. I cannot even begin to tell you, we have customers, or I have colleagues and customers I've worked with that sign the code, but they don't verify it. So what's the point of signing if I don't verify the signature before I deploy? Right? So those are critical steps along the way. Again, what I see a lot of is not a lot of people are doing this step, or they're doing it out of band. They're doing it with different tools or manually. And so let's focus on that a bit. Securing your code with code signing is one of the most overlooked components I see. And if you're not signing it, it's critical. And what's interesting is how the signature works is you use common tools, and you're going to learn more about this later if you don't know about it, but common tools will actually do a hash, and it'll completely secure that code stack. And the whole point of it is that a rogue developer cannot open that binary and inject their own code. And if you guys have seen Office Space, old school Office Space, where the guys actually wrote some code to take fractions of a cent, that's what we're trying to avoid, right? We want to make sure that what we're deploying is what we've tested. We know it's right. And if you leave it open, and we talk about secure repo, we talk about devs not building and signing. If I'm a rogue dev, I can inject my own code. It's easy to manipulate a jar file or a .NET package. It's easy to do, and if you're not verifying, then you don't know. So let's talk about where you guys are. Whoa, that just got loud. Hey, I'm here. Thanks for listening. I appreciate it. Let's talk about what I see. So there's a lot of people at the level 0 not signing code. If you're not signing code, it's time to start thinking about signing code. Right? You have to sign your code. And what's interesting is it's not just what you deploy, but it's what you pass around in the office. If it's an Excel file with macros, if it's a PowerShell script, you don't know, and that's where vulnerabilities hit. Right? So a lot of companies are locking down machines so they will not install code that's not trusted, because that's where all the vulnerabilities come in. So I know you all are familiar with phishing. I click the link, something gets downloaded, installed on my laptop, next thing you know, I have malware. So you lock that down, well then now I can't run code that's not trusted. So you need to make sure you sign your code, you need to make sure you lock down your environment so that things can't run. A lot of people not signing code, time to start. Level 1, we have a lot of people who are fragmented. We're doing some signing, we're doing some things, but the developers do it. Well, that's out of band. It means that they're passing the keys around. So if you have keys on USB sticks that you're passing around from team to team, guess what? Anybody can open that. If I take that USB stick home, I'm signing code. I'm signing whatever code I want, right? So you have to take that away from the devs and move it out of band into a pipeline, secure and safe, away from that process. Level 2 folks are centralized. That's where you want to be. I want a centralized process, protects my keys, it gives me auditability, it gives me a way to set policy, who can sign what, where, and when. But again, you need to move it to the final pieces into my CI/CD pipeline. It needs to be automated. It needs to be automated. So if you go back to where I started with the steps of your pipeline, it should be the final build step. You sign the code, right? It should be part of that automated pipeline before it goes into a repo. Once you get to this level, your risk is very low because everything's automated and secure. So just a couple of fun issues. Some of them aren't even on here. One of them I think is super interesting is some people found old certificates, code signing certificates with the private keys in a GitHub repo that were Microsoft keys. And these certificates were expired. Running out of time, got to start talking faster. These certificates were expired. Here's the interesting thing. Someone wrote a hack, and you can find it out on the web. It's called F signing, and the F, there's more to it. You could use your imagination. But it actually will ignore the expiration date on that cert, and it will sign the code. Crazy, right? Because the private keys were available. So there's no way to protect that. So what do we need to do? We need to keep our private keys in an HSM at all times, right? Super important. You'll learn a ton more about this, attestation and the like. Anyway, last shameless plug, Keyfactor Signum, which you'll learn more about today, is that product. Keeps your key safe in an HSM. You have key attestation for public use, final policies and controls, who can sign what, where, and when, etc. 2 more talks later today. If you're interested, please, actually one of them's in this room next, and then another one later today for more information. And that's it. Thank you so much.